Hey guys. Um, Hopefully you have taken your quiz now and done really well. And then you hopefully did the Mastery Connect pre-test about our next lesson here, which are states of matter. Actually, this is going to be the next two lessons. We're going to kind of combine them into one. But some of this information you might have had with Miss, I always want to say Kuchenbecker, which was her maiden name, Mrs. Davis last year, but I'm not sure. But anyhow, by the end of the lesson, um, you're going to be able to discuss how particles move in solid, liquids, and gases. Okay, so our goals for this lesson are these. I want you to be able to state that the particles, so the atoms or the molecules that make up matter, are always in motion. Even in a solid, when it's going to seem like they're not moving, that they're standing still, they are in motion. Okay? And then you're going to be able, let me get my camera right, you're going to be able to tell how they move in a solid, a liquid, and a gas. Okay? And then you will infer or make an educated guess of how the movement of the particles, again, the atoms and the molecules, in solids, liquids, and gases affect the properties of solids, liquids, and gases. That will all make sense in a few days. Okay. The same standard we've been using for months now, or weeks at least. All matter is made up of particles called atoms, and we're adding a new one this time. Changes of state are explained by a model of matter composed of atoms or molecules that are in motion. All right, so let's just look at the introductory activity here. Fill in the blank with a word or phrase that you think correctly completes the following sentences. What do we think? An example of a solid. Well, they said ice. Ice is obviously the solid form of water. Lots of solids out in the world. How about a gas? Gas might be a little more difficult for you to think of, but air is a good one. Air is gas. So, unlike solids, what do we think gases can do? Any thoughts? Well, and this is real important. We're going to talk about it a lot. They take the shape of the container that holds it. Okay? So I can put this remote, okay, into a bigger container and it's not going to take its shape. Okay? But a gas would. All right. Well, let's look. That activity was about solids and gases. Let's look at some liquids. They want you to unscramble the letters. So what do we think? A liquid with these letters. That would be H2O, water. Ooh, this one's a little harder. I personally like mine in the orange flavor. There's tomato, there's all kinds of different ones. That would be juice. Okay. Ooh, this one gets a little harder. What do we think? That's a lot of letters. Rivagang. You want to unscramble it? Vinegar. Some of you might not even know what that is, but it's used to cook a lot. Okay, next one's pretty easy. Maybe you have it with your cereal. That's milk. Last one's a little bit longer again. Need a second. Shampoo, what you use when you wash your hair. All right, next activity. Just look at the context that it's used in, make Mrs. Stout proud, that can give you a clue as to what the word is. So in this example, solid is the state of matter that has a definite shape and volume. So what do we think definite would mean there? Constant, fixed, steady, doesn't change, all of those words. Next example, occupy. So as it says, a large container will allow a glass to occupy more space. Think to yourself what a word for occupy would be, and that means take up. Okay, fill. All right, so now we're going to start looking at how particles move in solids, liquids, and gases? Well, there is something called the kinetic theory of matter, and that will be our next unit after this. But the kinetic theory of matter is all that an object's state is based off the speed of its particles. So what state of matter it is in depends on how quickly the particles are moving or slowly. So here are some things you're going to need to memorize, I think. I'm not big on memorizing, but this is stuff you need to know. So a solid has a definite volume. Solid's volume is not going to change. The length, the width, the height are constant because it's a solid. Its shape is not going to change. A solid doesn't suddenly morph into something else. A solid is a solid. The atoms are very close together, but remember from a few minutes ago, they are moving. They're vibrating in space. Okay. So the closer the particles are to each other, the denser they are. So it says here, atoms in solid steel are closer than in liquid steel. Okay, and that's why they're a solid. All right, here's a question that you are going to have on your classwork for today. How are the particles in a solid like people sitting in a movie theater? Well, let's look at these people all in the movie theater back in the days when we could go to a movie before the pre-pandemic times. So how would they be like a solid? Well, they're sitting in their seats, so they're all rowed up, okay? But they're just moving a little bit like in their chairs, all right? Well, that's how a solid is. The particles are locked closely in, just like these people in a seat, but they're vibrating in place. So think about a solid being, the particles in a solid being like people in a movie theater. All right, next we're going to look at liquids. So a liquid has a definite volume, but not a definite shape. So what I always like to think about is look at my water here, okay? I drank some of it, but it is 1 liter, okay, or about a quart, okay? Its volume is not changing. Let's say it's full. This is a bad example, but its volume is not changing, but its shape is. If I pour this into a sink, its shape is going to totally change. So how much there is of it, the volume doesn't change, okay, but its shape will. So atoms, and this is real important here, atoms in a liquid have more kinetic energy than in a solid. So they are moving more, but they're still a little bit attracted. They're not flying all over. They're still a little bit attracted to each other, but not like a solid. Okay? So because the attraction is less than in a solid, liquid particles move more easily and take different shapes. Just like this, if we pour this into the sink, it's going to take a different shape. All right, next question on our work for today. How are particles in a liquid like people in the movie theater lobby? So now they've left the movie theater and they're walking around the lobby. So how can we compare liquid particles to that? All right, well, people in the movie theater lobby can move around freely, so they're not stuck in their seats like before, and like in the solid comparison, okay? But their motion is limited by the people around them. So if it's crowded, they can't go wherever they want. They can move, but not as freely as they want. But they can still like slide past each other and get to wherever you want to go. That's how the particles of a liquid work. Okay, now lastly, we have a gas, and it has no definite volume or shape. Particles in a gas go wherever they want, and they have the most kinetic energy. If you kind of relate kinetic energy to temperature, think as you like boil water, the temperature goes up, the kinetic energy goes up, those particles go flying everywhere. Okay. So the space or the area between the gas particles will go up as the temperature goes up, or the kinetic energy goes up, or it goes down, depending on the temperature. All right, your last question that will be on your assignment for today is how are particles in a gas like people outside of the movie theater? So we've left the mall, the Marion Mall, Polaris Mall, wherever you go see movies or did before the pandemic. How is that different than being in the theater or being in the lobby? Well, people are spread out, can go wherever they want. Johnny can go home, Susie can go out to eat, you can go wherever you want. That's how particles in a gas work. They move freely and have a lot of space in between them. All right, that is it for today. I know it was a lot. We will discuss this for quite some time because, as I said, we're going to have 2 lessons. 3 easy questions for homework today. Make sure you screenshot them and submit them to me through Canvas. Please do not email me because I get a lot of emails and it gets lost in there. So just simply screenshot it, submit through Canvas. Okay? All right. Hope you did well on